What happens to the human mind when it is millions of kilometers away from Earth, suspended in the vast and infinite silence of space? This question has fascinated scientists, astronauts, and dreamers for decades, fueling imagination and pushing the limits of our knowledge. The human body, while being an extraordinary biological machine, faces unprecedented challenges when confronted with the space environment. Space, with its extreme conditions, is not just a physical place but a test of human cognitive, emotional, and psychological abilities. Today, we will explore how the conditions of space travel affect the human mind, focusing particularly on cognitive difficulties and adaptive responses astronauts must deal with. Imagine being an astronaut aboard the International Space Station, ISS. After months of intense training, you are finally in orbit. Each day brings new challenges. Outside the window, Earth appears small, a blue and white globe floating in a sea of darkness, distant and inaccessible. But inside, your life is anything but calm. You are suspended in an environment where gravity no longer anchors you, your body floats and constantly readjusts. Sleep is fragmented, irregular, and cosmic radiation constantly bombards your body, threatening every cell. A small mistake can jeopardize not only the mission but also your life. The mind, therefore, must cope with physical and psychological stress like never before. How does the human brain keep up under such extraordinary circumstances, where every decision and every movement can have enormous repercussions? This question is at the center of studies conducted by NASA's Behavioral Health and Performance Laboratory, one of the most advanced research centers in the field of space neuroscience. The laboratory carried out a study on 25 astronauts who spent approximately 6 months aboard the ISS, seeking to understand how microgravity and space conditions affect cognitive functions. The results of this study, while surprising, reveal a complex and nuanced picture of the human brain's responses. The human brain, in fact, proves to be incredibly adaptable. At first glance, no signs of neurodegenerative decline or significant cognitive impairment were observed during the 6 months in orbit. According to Shin Dev, lead researcher of the study, this demonstrates that, at least in the short term, the brain is capable of withstanding the challenges of microgravity. However, not everything is positive. Although no evident signs of permanent damage emerged, certain aspects of cognitive performance showed signs of vulnerability. Processing speed, working memory, and attention appeared to be the most affected areas, with noticeable difficulties in making quick decisions and maintaining focus on complex tasks. This phenomenon is not surprising if we consider that, on Earth, stress, fatigue, and cognitive loads already impact mental performance. Imagine facing a long workday under stress or a night of insufficient sleep. Multiply these difficulties with the external factors of the space environment, and the result is an extraordinary cognitive load. In fact, astronauts constantly face conditions that exponentially increase the level of psychological stress. Isolation, the absence of immediate communications with Earth, the constant fear of mistakes with potentially fatal consequences, and the continuous bombardment of radiation. Despite these challenges, astronauts develop strategies to cope with these difficulties. Scientists believe much of this adaptation comes from rigorous training and the acquisition of specific skills. The ability to solve problems, for example, compensates for reduced processing speed. This mental resilience is a testament to the extraordinary adaptability of the human brain. NASA's research is not limited to understanding astronauts' cognitive reactions. It has crucial implications for the future of space missions. Missions aboard the ISS are just a taste of the challenges that lie ahead. Future explorations of the Moon and Mars will take astronauts into even more extreme environments, where prolonged exposure to radiation, total isolation, and communication delays will pose significant obstacles. This study provides a fundamental basis for developing targeted strategies that can protect astronauts' mental health during these longer, more demanding missions. Identifying which cognitive areas are most vulnerable allows for personalized interventions, such as specific mental exercises, advanced technologies for monitoring mental well-being, and improvements in living structures aboard spacecraft. A fascinating aspect of these studies is the discovery that the human mind is not static. It can adapt and evolve in response to extreme situations, showing remarkable flexibility. Its ability to recover and find new solutions to problems never faced before is extraordinary proof of our resilience. This research not only sheds light on the difficulties astronauts face in space but also tells us how the human mind can evolve when put to the test. Ultimately, what happens to the human mind in space? It is subjected to stress, challenges, and extreme conditions, but it does not surrender. It adapts, grows, and finds new ways to face the unknown. With the prospect of even more ambitious missions in the future, such as those to Mars or Jupiter's moons, the insights from these studies are fundamental. Space exploration, in fact, is not only about conquering new worlds but also about a deeper understanding of our own inner universe. If this topic fascinates you and you wish to explore the mysteries of space and science, you are in the right place. Every video is a journey among the stars, full of curiosity and surprising facts. From the study of gravitational waves to the secrets of black holes, we explore together the most fascinating enigmas of the universe. Subscribe to the channel and activate the bell to avoid missing new videos. Leave a like to let us know we are heading in the right direction and to help us create more and more quality content.